Okay. Sorry, Jordan. Thank you for reminding me of that. All right. Okay, and so whoops, sorry. No, you're good. So the main deal here, the theme is with rational numbers is that we are, what do you got? Okay, the main thing here is that since we're going to be dealing with rational numbers, we're going to be dealing with what particular kind of number? Fractions, okay? All right, and so we're going to work a little bit on simplifying fractions to start with. Okay, so if I'm going to simplify a fraction, for example, 9 times 55, what I need to do is I need to break the top number and the bottom number down into a smaller and smaller multiplication problem. So somebody raise your hand and tell me a number that goes into 9 evenly, please. Matthew? Okay. How many times does 3 go into 9? 3. Okay, so I can rewrite 9 as 3 times 3. All right? Now, obviously, 1 goes into that too, but we're not going to worry about 1 because 1 goes into everything. Okay? So the farthest we can break 9 down is as 3 times 3. All right? Raise your hand and tell me a number that goes into 55 evenly. Kara? 11. All right. And how many times does 11 go into 55? 5. Okay. And is there anything that goes into those things? What are the fancy words? What's the fancy word for those numbers that can't be reduced at all? Yes. Nope. Starts with a P. Nope. Prime numbers.
Yeah.
Those are prime numbers because nothing goes into 3 besides 3 and 1. Okay? So now that I have it reduced to 3 times 3 and 11 times 5, are any of the numbers on the top the same as the numbers on the bottom?
No.
No. So it turns out that these cannot be simplified. So that's kind of a silly one to start with. So 9/55 has to stay as 9/55.
What does prime numbers mean?
Prime numbers means that the only numbers that go in there evenly are 1 and the number itself. Okay? And so since we have 2 numbers here, this isn't super important, but these 2 numbers, since they can't be reduced, are called relative primes. Okay? So they're not prime numbers themselves, but since there's no number that goes into both of them evenly, the same number goes into both of them evenly, they are called relatively prime. That's a little quacky. All right? So let's try one that will reduce. So let's go with negative 24 over 32. What is a number that goes into negative 24 evenly, Matthew? 2. Okay. And it goes in there 12 times. What's a number that goes into 12 evenly, Austin?
2. Oh wait. I was gonna say the answer.
Well, let's go. Oh, well, we got to work through this a little bit. So this is 2 times 12. Now we're going to reduce to 12. How can I rewrite 12? What times what?
6 times 2.
6 times 2. Okay. Is there anything in there that I can rewrite? Yes.
3 times 2.
Okay, good. The 6 can equal 3 times 2. And then we're done. So negative 2 times 3 times 2 times 2. Okay? So breaking that down into the smallest pieces that we possibly can.
Why do we have to break it down?
I'll show you in a second. What is a number that goes into 32 evenly?
4.
Okay, 4 is good. 4 goes in there how many times, you know?
8 times.
8 times. Okay, now break down, somebody break down 4 and 8. Jordan?
2.
Jordan? Where you break down the 8? Okay, so 8 breaks down into 4 times 2, and 4 breaks down into 2 times 2.
That's right. I wrote number 1.
Okay, and then there's one more piece that I can still simplify this. What does 4 break down into, Ben? 2 times 2. So 32 turns out to be 2 times 2 times 2 times 2 times 2. Okay? So, are there some things on the top that are the same as the things on the bottom? Yes. Okay, and so I can cancel those, I can cancel those, and I can cancel those. What am I left with on top?
3 times 2 times
I'm left with a 3 on the top, the negative 3 even, and a 2 times 2 on the bottom, which is 4. Okay? So negative 24 over 32 breaks down or simplifies into negative 3 over 4. Now some of you want to do this a faster way, which is totally fine. What is 2 times 2 times 2?
6.
8. 2 times 2 is 4 times 2 is 8. So a faster way that we could have done it is we could have recognized that 8 goes into both of these numbers evenly. How many times does 8 go into 24?
3.
3 times. So 24 divided by 8 is 3. How many times does 8 go into 32? 4 times. And so that works like that also. So if you can find a number that goes into both of them evenly, you can just skip that breaking it down step and divide them each by that number. Okay? If you can't think of what that number is, then breaking it down like this is a good way to figure out what it reduces to. Carla?
That's called like greatest common factor.
Yeah, something like that. The old greatest common factor is in there somewhere. GCF. Yeah, always find the GCF.
ECF stand for?
Greatest common factors.
Oh, you said that.
Okay, so let's now take a look at how to take some of these decimals and write them as fractions, because we said that a decimal number is in fact a rational number, which means it can be written as a fraction. So let's take negative 5.59 and write it as a fraction in simplest form. Okay, so the negative 5 stays as a negative 5. Okay. How do the numbers go after the decimal place? For example, if I have numbers before the decimal, I'm sure you all remember, this is the ones, the tens, the hundreds, the thousands, right? How do the numbers after the decimal place go? What's the first number after it, Oscar? Carla? The hundredths is this one right here. Right, this is the tenths, because one decimal place means 1 0. This is the hundredths, because 2 decimal numbers means 2 zeros. This is the thousandths and so forth, okay? So how many decimal numbers do I have after the decimal here? 2. So I'm going to go 59 over 1 with 2 zeros, okay? So that's my first starting point. Now that I have 0.59 written as 59 over 100, is there anything that you can think of that goes into 59 and 100 evenly? No. So that's it. That's in simplest form. We are done with that one. Okay? Let's try this one right here.
So we just take the 2 numbers after the decimal and put it into 100.
And that's how many zeros you need. Yeah.
Oh, but we put negative 5 up there. So
Yeah, I guess so. Pretty easy. We'll see. Okay. So if I want to convert this or write this as a fraction, how many numbers are there after the decimal point this time? 4. So how many zeros do I need? 4. So I'm going to write 5714 over 1 with 1, 2, 3, 4 zeros. Okay? Now, thank you. This one I can reduce. Okay? Can anybody think of an easy number that goes into both of those evenly then? Okay, 2 goes into both of them evenly for sure. So let's figure out what we'll have when we do that. 5 divided by 2 is 2. Multiply those together gives me 4.
17.
Hold on, slow down.
8.
Slow down, please. 5 minus 4 is 1. Bring down the 7. 2 goes into 17
8 times.
8 times. If I go 8 times 2, that gives me 16.
5.
So subtract those. That leaves me 11. 2 goes in there 5 times. So that's
7.
10. Good. And then I have 14. So that is 7. So 2857 over, what is what is 10,000? Okay, that one's an easy one to do. That one is 5,000. Okay?
Wait, so
That's
if
5%.
Then you can't do it yet.
How do you get the $5?
Well, we just did it in our head, but if you can't do that in your head, you can do it the same way as we did the other one. We're going to divide that by 2. How many times does 2 go into 10? 5, and it goes in there perfectly.
Sorry, I saw the one, you pointed to the one side.
Yeah.
I knew
Okay.
it was 5.
All right? Right, no, it doesn't go, yeah, no, you're right, okay? So sometimes, decimal numbers, when you write them as fraction, can be reduced, and sometimes they cannot. So be careful with that, all right? Okay, then the last thing we need to do today, and then I'll give you your assignment, and hopefully you can get it done before you leave so you don't have to have any homework.
wait, are you going to give us a big assignment?
Nope, be the same as always.
Yes.
Okay, we're going to write each decimal, each fraction as a decimal. So now we're going the other way around. Okay? So the deal with this is what you have to understand is when you read a book or a magazine or a newspaper in this country, where do you start? But if you're looking at this page, when you read what I wrote on this page, you start at the top left, and you go to the right, and you go to the bottom. Okay? You go left to right and down. Okay? So 5 over 4, okay, is 5 divided by 4. Okay? Okay? 5 over 4 is 5 divided by 4. Top number always divided by bottom number. So if I'm going to write that as a decimal, then I need to go 5 divided by 4. Okay? Does 4 go into 5 evenly?
Oh.
No.
Yes.
So instead of
Oh,
doing
no.
what Jordan said and having a remainder, I'm going to make a decimal point and add some zeros. Okay? And then that means that the decimal, hey, I don't want to lose you guys right now. Matthew, keep your attention this way. Nope, I don't want any questions right now. Okay? So the decimal point of my answer goes right above the decimal point in the problem right here. Okay? All right? So now we're ready to do our division. How many times does 4 go into 5? Once. So then I go 1 times 4 is 4. Subtract 4 from there and get 1. And then now I'm going to bring down the 0. How many times does 4? 2. 2 times 4 is 8. Subtract those and then bring down the 0. Good. And then 4 goes into 25 times. And so now you are done. 1.25. Carla?
How come you added 2 zeros? Because I thought that you were
I could have added 3, 4, 5, 6, or 7. I just guessed 2. As soon as I reach a point where this number goes into that number evenly, then I'm done.
I thought you put like a 0 and then a dot and then
No, you put the starting number right here and then a dot and then as many zeros as you need to get to an even answer. Okay? Matthew?
Can you just do, I used to just do another, if 4 was
Yeah, you just figured out.
less than that,
Yeah,
then just
right.
put
That's
the
fine.
rest of it.
Yeah,
Wait, so why can't we just divide 5 by 4?
that's what we just did.
Yeah.
Like, you made it like into a decimal.
Yeah, you made it really complicated.
That's what you get when you divide 5 by 4 is you get a decimal.
Yeah, 1.4 equals 4.
Oh, so like if you divide 4 by 5, it's
4 divided by 5 would be a different decimal, that's 0.8. 4 divided by 5 is 0.8. Okay, so Jordan wants to know what happens if we go the other way around. What? Okay, so let's say, put your hand down, I'm not calling it. 4 divided by 5, okay, 4/5 in other words. So now we're going to switch it around, 4 divided by 5. So this time the 4 goes inside and the 5 goes outside, okay? So Carla, let's make a guess. How many zeros do you think I'm going to put after the decimal? 1, okay. How many times is 5 going to 4?
0.
0. How many times is 5 going to 40? 8. And since it goes in there evenly, I am now
So,
done.
done.
Right. So 4/5 as a decimal is
So
0.8.
then why did you add a bunch of zero?
Oh, because Carla asked me why did I stop. Hey, it's
Dude,
all right.
shut up.
Hey, Jordan. Jordan, I don't want you to tell people to shut up. Okay?
It was
take
kind
care
of hard.
No, listen. Hey, listen. Okay? I'll take care of that. Okay? So the reason why, Jordan, I'm still working with you. The reason why I put a bunch of zeros on there is because Carla asked a question. I don't need those zeros regularly. All right? Okay, let's do one more. Hey. Let's do -1/6 as a decimal. Okay? So in this problem, the main thing that I hope you understand is, am I doing 1 divided by 6 or 6 divided by 1? 1 divided by 6, because it's the top number divided by the bottom number, okay? So if I go 1 divided by 6, obviously 6 doesn't go into 1 evenly, so I'm going to need some decimals. Jordan, how many zeros do you want me to try?
200.
1, okay? So 6 goes into 10 how many times? 1.
4?
Okay, well he's thinking of the remainder. Okay, so 1 times 6 is 6. If I subtract that, I am left with 4. So since I have a 4 here, I need to add another 0. How many times? 5 is 30. I can do one more 6. Yeah. Okay. 6 times 6 is 36. So if I subtract those, I get 4. So I need another 0. Okay. Right. 6. Yeah. Right. And so what you should see is, since we're stuck in a little rut here. Right. Every time. Good. Hold on. Don't interrupt. Every time we do this problem, the remainder is going to be the same, so we're stuck in a loop. So we have 0.1666666 going on forever. And so as most of you have said, we write that as 0.16
Oh, that's it.
with a bar only, Jake?
Yeah?
Only over the 6. Okay? The 1 is not repeating, the 6 is. All right?
Yes.
Okay, so to simplify a fraction, what do? The very first problems that we did, to simplify a fraction, what do, Ben? Find the number that goes into both of them evenly and divide them both by that. Okay, good. To write a decimal as a fraction, what do?
Divided by that number.
So it's already a decimal, so it's already been divided. What do? Somebody besides Ben? What do to write a decimal as a fraction? Really? What do to write a decimal as a fraction? No?
You put it over 100.
Put it over 100, or it might be over 1,000, or it might be over 10,000. Good. The number of numbers after the decimal tells you how many zeros. And then what do to write a fraction as a decimal? Yes?
Turn the fraction. Wait.
Simplify.
Nope.
You divide it by 100.
Not by 100.
I don't.
You divide the top number by the bottom number.
I was going to
Okay?
say turn it into a decimal, but you said something about decimal, so I was like,
Okay.
We should do all these problems in a book because there's.
Mr. Aldridge, we're going to see this part. Have you seen Mr. Aldridge?
No, I already know you can't.